Hey guys, welcome back. And so in our today's video tutorial, we are going to look at how you can configure router on a stick, that is implementing a layer 3 communication. So I hope you are familiar with the packet tracer. So these are our labs. We are going to implement communication using packet tracer. We are going to use our router. The router we are going to use is 1841, and also we will use our switch. So we'll use our first switch here. Then we select the pieces. So let's say we select how many pieces. So we have got 3 pieces. Then also you can also select a server. So a server here. So the server and this PC2 here, they are on the same VLAN, so that they will be able to communicate with each other at their VLAN level. But now when they want to communicate with the other PCs, now is where they will implement what's called inter-VLAN communication. So you select the cable, you connect your cables, connect to the router, and you connect from your switch here to the other PC. And lastly, we connect to our last PC, not PC, our server here. So actually, this is now the work that we are going to implement. So you can highlight, can draw an ellipse. So this one is VLAN 10. Then can give it a text. So say this is VLAN VLAN 10 with a network of 192.168.10.0/24. Gateway will be 192.168.10.1. VLAN 20 address will be 192.168.20.0/24. Gateway being 192.168.20.1. So that's it. So like here, PC1 here, you can give this PC here .20. This one you can give git let's say .10. Then this other one is .11. .10. .11. So we all know that when we want to implement layer 3 communication, we can either use a layer 3 switch, or you can use a router. So with our router, we are going to create a sub interface on this router here. So here we have got first Ethernet 0/0.10. The address will be 192.168.10.1. Then first Ethernet. That one will act as the gateway for VLAN 10. Then first Ethernet 0/0.20. .20. That one will act as the gateway for VLAN 20 192.168.20.1. So that's, I think that's now the lab preparation. So that's what we are going to configure in our practical. So it goes straight away into our switch here. Go to the CLI. So in our CLI, first of all, in enable command, use the enable command to enter the privilege executable mode. When you want to enter to the global configuration mode, you're going to use the config terminal, config T. So in the global mode, this is where we are going to set different configuration. We are also going to set the password for this our device so that we ensure that it is secured from only authorized persons. So first of all, we give it host name. So host name, this one will be switch 1. After I give it, now you can see the name has now changed from the original switch now to switch 1. After that, what we do, we are going to now set the password for the global mode. So now when you leave the privilege executable mode, you should be able to be popped with a password. So enable password. Now the password, we can just use a simple password of Cisco. After that, we are going to now set the password for the console. So line console 0, password we also set to Cisco so that you use the same password that we don't forget. Now you ensure that this password it is you are popped with the password every time you log in. So you type login every time you need to log in. So login. Also, for if in case you want to manage your devices, your switch from a remote computer, you can also create a VTY. So line VTY 0 to 4. Set the password to Cisco. So that every time you log in, you are popped with the password. So after that, we are going to create what's called a banner. So why do we need a banner? So the banner is set to warn unauthorized users that access is prohibited. So like let's exit from that mode. Sorry, exit. Now you set the banner message of the day here to be, let's use any symbol. You can use any symbol. Let's use the $sign. So we are being told here, enter a text that end with the $sign. So I'll use this hash. Then I give the word that I want to appear. So only authorized users. Then after that, ensure that after everything, it ends with the dollar sign, the word that we set as the message of the day. Now, after that, I think you can now exit and now see if so exit again. So you see here, they have popped with the message of the day here that only authorized users are allowed. So now they require you to type your password. So our password was Cisco. Now that one now is now you are now in the privilege executable mode. Now to get into global mode, configuration mode, now you use the enable command. That one you are still in the executable mode. Now they are asking you to verify. So give your password Cisco. Now to enter the global configuration mode, use the config terminal. Now you're there. Now from this point now, we'll now be able to continue with other configuration while we know that our switch is now secured from unauthorized users. So here we are going to create we are going to create the interfaces on this our switch. So when you look at this switch, it has got four interfaces: the interface that connect to the downward pieces, and also the interface that connect to the router app. The interface that connect to the downward switches, this one to the downward pieces, sorry, will now act as the access ports, while the one that connect to the router will be a trunk port, which will allow VLANs from multiple, which uh, allow multiple VLANs to pass, while only access port allow only a single VLAN to pass. So you create the VLANs. We're going to create the VLANs. So VLAN 10. On VLAN 10 here, we're going to give it a name of, let's say this is sales department. Then VLAN create VLAN 20. VLAN 20, we give it a name of, always use a tab key to autocomplete your configuration. So VLAN 20, we give it production. Now we are going to add the interfaces to our VLANs. So you exit. After exit now, what we do is create the interface. We're going to create the interface interrange, because when you look at here, interface first Ethernet 0/0/2 up to 3 belongs to VLAN 10, while from 4 to 5 belong to VLAN 20. So we create a range. So interface range first Ethernet 0/2 to first Ethernet 0/3. So both of those interfaces belong to a switch port. So switch port mode here will be access. So we tell it switch port access VLAN 10 here. So both of those two belong to VLAN 10. Then we enter interface VLAN if range from VLAN interface range from 4 to number 5. Also, these are an access port, and access port here is allowing this for access for VLAN 20. You can see here the interface that have been added to this our VLANs that we've named sales and also production. It's first Ethernet 2 and 3 are on VLAN 10, and first Ethernet 4 and 5 are on VLAN 20. So like let's exit from that view. So exit. and also so exit again. So while you are in this view, now you don't need to use the do command. You just type show VLAN brief. You are still able to receive the same command, but like while you are in that global view, you don't need to come back to the privilege executable mode for you to be able to use the verification command. So just use the do. When you add the do command to all those other commands, every command should be able to be executed at every at different view where you are. So that's let's go back to our global configuration view. So config enable big terminal. So we are in that on configuration terminal there. So like here we've not configured this interface that connect to the router. So that is first Ethernet 1. So interface first Ethernet 0/1 switch port here, switch port mode. These are trunk port and switch port trunk. Trunk is to allow the allowed VLANs will be VLAN less. We are going to allow VLAN 10 and 20, so we'll have VLAN all. After that, I think we are done with the switch, and now what we do is just save our configuration. So like I said, in every when you are in the global configuration mode, you don't need to go back to the privilege executable mode to save or use the display command. So you just use the do copy running configs. So they will ask you, do you want to save? Now just click enter. Then everything has been saved. Our router here is where we're going to configure the sub interfaces, because like here we have got only one physical interface, that is first Ethernet 0/0/0. But in that physical interface, we've created two sub interfaces that are going to help communication within the VLAN 10 and VLAN 20. They are going to act as the gateway for those two VLANs. So you come to our router here, go to the CLI, say no. So enable. On the configuration terminal, we're going to enter the interface. So interface first Ethernet 0/0. Like when you look at this interface here, you see it is still in red, because means that the interface is still down. So we are going to bring that interface up. So while you are on that interface for Ethernet 0/0, I want you to see as I configure and how it turns on. Now just tell it no shutdown. So you see it has turned to green immediately. After that, now the link is up. Now we are going to configure the sub interfaces. So exit. So before we configure the sub interfaces, I want to configure the IP addresses to these our PCs. So give them IP addresses. So this one 10. 192.168.10.1. Come to this other one. Also give it IP address 192.168.10.11. It will automatically pick the subnet mask. Then we give it the gateway. So .1. Then we go to this other PC here. In this our PC, its IP address will be 192.168.20.11. We'll pick automatic subnet mask. Now we configure the gateway 192.168.20. Then we go and configure our server here. That's the give it IP address here 192.168.20.11. Then give it the gateway of 192.168.20.1. And let's see if we can ping this hour on the same VLAN. So ping 192.168.10.11. You see, it's able to reach when we ping our PC here. While we are on PC 0 here, we are pinging now PC. We are pinging PC2 here, PC1 here. So because they are on the same VLANs, meaning that they are in the same subnet, they will be able to communicate because they are on the same network. But now, also when you come to this side, this PC should be able to ping the server because they are on the same subnet. So ping 192.168.20.11. It's able to return packets successfully because they are on the same subnet. But now, what about if you want to ping from this PC1, PC0 here to PC2? So PC2 here is .1. So come to, you see, you will be told the request timeout because you see now here, you are being told the request timeout because it doesn't know the network where the host, the destination is. It can't reach the destination. It can't even find the gateway for 192.168.20.1. So to implement that, like now we want to implement communication between the persons on VLAN 10 and also the person on VLAN 20. So that's where we are going to implement a router on a stick, where we're going to configure the sub interface, and the sub interfaces are going to carry the default gateway, so that when you send packet to that gateway, it will realize that, oh, this is the gateway. This sub interface contains the gateway of the network where you want. So now we go to our router here. So on our router, we are going to create the sub interfaces. So interface first Ethernet 0/0.10. You can see here it has told you that that's a sub interface. So on that sub interface, we are going to now configure the .1 queue termination so that whenever it receives the packets from VLAN 10 or 20, VLAN 10 should be terminated. So now use the encapsulation .1 queue. Then the VLAN here is VLAN 10. Also, we enter to the sub interface of first Ethernet 0.0.20. The encapsulation here we are using .1 queue. Then the VLAN here is VLAN 20. Sorry, let's go back to our sub interface VLAN 10. .1 queue. Then we give it IP address. So the IP address for that sub interface will be 192. Note that before you configure this command here, encapsulation mode .1 queue termination, that interface won't be able to accept the IP address configuration. So you need to configure this command first. Is when you configure this. So 192.168.10.1 subnet mask of 255.255.255.0. Sorry, I didn't specify the term IP address. IP address 192.168.10.1 subnet mask of 255.255.255.0. Then you enter subinterface of VLAN if 20. Then encapsulation mode here, VLAN if 20. IP address here will be now 168.192.168.20. That subnet mask. So I think with that we are now done. We are going to save the configuration. So do copy running config start, enter. Now let's see now if we are now able to ping. Let's see if now we are now able to ping the network. Are still not able to ping, so let's give it time as it speaks. So now you see it has now picked. So only one packet has been lost because the interface was not active yet. So let's now ping again, see if now we can receive all the successful packets. So you see it's now able to ping, like this PC1 here is able to talk to PC2 and also able to talk to the server, that is the 1.11. PC0 here is able to communicate with the PCs on these other different VLANs. This has been implemented with a router, or you can also use a layer 2 switch. So layer 2 switches, layer 3 switches, layer 3 switches we have here. This one here and this one, those are the layer 3 switches. They will help you to implement inter-VLAN routing, inter-VLAN communication. So the good thing with Cisco Packet Tracer is that you'll be able to see everything that happens. So like you come here and you click the simulation mode here. Now every time you run a ping service, like you want to ping on our server. So now we ping our server. You see here you see the PDU packet here. Now we want to see the process. How does the flow continues? So now you come here, you click, and you will be seeing how the PDU packet will be traveling. When it gets to the switch verifies and look at the destination where it needs to be forwarded. After that, it's forwarded to the destination. While you look at that packet here, you can see here it's a layer 2 packet.1q termination. So you are being told here the source MAC address was found in the MAC address table of the switch. This is a Unicast frame switch. Looks into the MAC address table for a destination MAC address. So that's what happened when the packet was sent to PC number 1 here. I want you to see how the packet now flows successfully. You see now, see how the PDU packet travels. It gets to the switch, then it is sent to the router. When it gets to the router now sends it to the destination. That is the switch now send it to the server. The ping service went on successfully, so we were able to ping, and now the TTL time was 127 seconds. So guys, that's how you implement VLAN communication, inter-VLAN communication. Like when we talk about communication within VLAN, that one we are talking about switching. But now when we have to communicate communication between, like from this VLAN to the other VLAN. Now that is when we implement layer 3 communication, either use a layer 3 switch or use a router. So thank you guys for watching this video. Stay connected for more videos.